I'm here with Aaron Parness. He's a director here at Amazon Robotics, and I'm here to interview him about his job.
Yeah, hi.
So just tell me a little about current job.
Yeah, I would say I kind of like get to live my robot dreams. So I have two teams. They're doing complementary projects. And so one is based here in Seattle. It's about 150 people, and we're working to give robots a sense of touch. And once robots have a sense of touch, they can start to do complex manipulation, moving items around, interacting in high clutter. And that's my team here in Seattle. My team in Berlin, Germany, is working on a picking problem. So rather than putting items into these cluttered environments, they're working on identifying the right item and picking it out of those cluttered environments.
And what was your path to get to this job?
Yeah, so I kind of got hooked on robotics, I would say, as an undergrad. My sophomore year in university, there was a competition. It's very similar to like FIRST robotics that they have today for high schoolers. And I just loved it. It was so much fun to build things and have the things you built actually move around. And so that's what got me excited about robotics. I also really loved being a student. And so I stayed in school a long time. I did a PhD. And part of that was to pursue the robotics aspect, but part of it also was just to still be on campus and have that kind of school schedule. I went from my PhD to NASA Jet Propulsion Laboratory. And so I was there for about 10 years, started, my own lab and kind of built up these research projects that were mostly done by teams of like 3 or 4 people. We would publish papers, we would kind of explore things. And usually those were like 2-year projects. And I came to Amazon 5 years ago. And in a lot of ways, it feels like a startup inside this enormous company. So the team on these 2 projects they started with 8 people and 3 people, and now they're, 150 people and, 80 people. So yeah, it's been super fun.
So what did you do your PhD thesis on?
Yeah, I did bio-inspired robotics. So we were looking at nature's best climbers, and this is the gecko lizard and insects. So we were studying kind of their mechanics, the adhesive pads like on the feet of geckos and these kind of claws that are on the feet of insects, and trying to make robotic versions of those. So I kind of built like robot feet. That was sort of the PhD, but they were inspired by animals.
Yeah. How did you come up with that idea or get into that sort of stuff?
Yeah, so for most PhDs, the student doesn't necessarily come up with the idea from scratch. I think that can be what you think it is. But in reality, you've got a professor who's been leading a line of research. And so the professor I had was interested in how humans grasp the world, so human hands, and then kind of extending that to look at how animals were using hands and feet to interact with the world. And so I kind of came into that environment and realized, the gecko was something I really wanted to prioritize because they have these incredible microstructures, even nanostructures on their feet. But I wasn't out of the blue. I was sort of in this line of bio-inspired research.
And how did you get into that? You said it started in undergrad?
Yeah, so I had this, competition where it was, 120 of us or something, building robots out of a kit of parts and competing. And that's what made me think robotics might be a good career for me. And then when I was looking around at different university programs for the PhD, a lot of times you're looking actually at the labs. So the school and the reputation, they matter a little bit. But I think actually what matters more when you do graduate work is who you work with, the professor within that school. And so I was looking at a couple of different labs, and if I'm being honest, I was just looking at what the coolest programs were. So gecko-inspired robots, bio-inspired robots are super cool, right? They make good YouTube videos, that kind of thing. I wasn't a practical, what's going to be the big business opportunity. I was just, what looks fun. And so there was a couple of those, some humanoid robot stuff. There was some other exoskeleton robotics. I got really lucky. The professor I had at Stanford, Mark Kokoski, was amazing, such a good mentor for me. And had a lot of fun.
And in high school, did you do any like clubs or stuff that made you want to even just start looking into
Yeah.
this?
So I'm fairly old. I'm 43 at this point. So in high school, we didn't have robotics teams in high school when I was, or at least not at my high school. And I did go to I went to a magnet school, so the Illinois Math and Science Academy. I was very into physics and math, and I was on the math team, right? So I got to like go do math competitions against some of the other schools in Illinois. Um, but there wasn't like a robotics club the way there is today. It's like so amazing that there are those opportunities for high schoolers, even like junior high or below. But maybe I'm an example. Like you don't have to start in high school to get into robotics. I started in college. Yeah.
And then you said you went to NASA for like many years.
Yeah.
What
So
did you
after
do
my
there? Yeah.
yeah after my PhD, I went to NASA Jet Propulsion Laboratory. That's in Los Angeles. So they're most famous for building the Mars rovers, and the Ingenuity helicopter is pretty cool. That's one of the most recent ones. I was doing more early stage R&D. So I was building grippers for comets and asteroids. It was kind of an extension of the climbing robot stuff I did in my PhD. If you're moving in zero gravity, it's actually much more similar to climbing, right? You have to have a foothold, or you fall off into space. And so I was kind of evolving those different kinds of grippers, also doing some sampling strategies. How can you drill into a comet, or how can you get regolith, which is what they call the dirt when it doesn't have any organics in it, like the sand of an asteroid. Or at the end, I was looking at icy moons. There's like some really cool, promising science targets in the outer solar system that are covered in ice. So this like Enceladus and Europa are moons out there in the outer solar system, and they have a liquid water ocean beneath this ice crust. And so you're like, okay, but they also have like 5% of Earth's gravity or less in some cases. You're like, okay, how could a rover get around on that kind of surface? And it's not ice like you have in the winter. It's ice that's at like a cryogenic temperature. So if the ice is minus 200 degrees, it's actually like rock hard. It's not. Anyways, this was a fun a fun challenge. Yeah.
And do you think that's like a typical first job?
No, I was so lucky. It's like a privilege to get to work on those kinds of problems. You definitely get to work on them in grad school. Like I do feel like PhD programs, master's theses, a lot of them are a little more sort of blue sky, or like they're a little bit more trying to push the state of our knowledge forward, rather than at Amazon, we work backwards from a business case. We're trying to think about how can we make this job safer, or how can we make the building more productive, or ship an item faster. It's very pragmatic. It's very like, it's a business. I do think at NASA, you're in this in-between phase where your business is scientific discovery. So yeah, it's not a typical first job.
Yeah. What do you say is like a typical position or job for someone coming out of college?
Yeah, I mean, there's so many. You can join a big company, and that can be good because you get to see a bunch of established mechanisms and like work habits. There's always going to be senior people there that can give you some training. But usually you'll have a smaller scope if you join a big company right out of school. If you join a startup, on the other hand, your job is basically anything that company might need, right? So one day you're assembling the lab bench, and the next day you're conducting, experiments on the lab bench, and then the third day you're, a media spokesman trying to get that result out there into the world. So a lot more flexibility, but less structure and like less mentorship sometimes at those small companies. I say this, I've never worked at a startup, so you shouldn't believe me too much on this. Yeah.
And what like skills or experiences do you think are really helpful when first getting into like the workforce?
Yeah. It's been changing. And so these days, I think one of the most important things is being fearless and being willing to go learn whatever the latest tool or technique is. And so trying to practice the art of learning new things, or leveraging stuff that might be open source or recently sort of published. That's a real powerful skill. If we mean like sort of hard skills, like I always tell people to be hands-on. Like if you can do project classes in college or in high school where you're building things, you get a very different set of experiences. And I think those experiences translate to the workplace much better than doing, a paper homework set or doing a computer model only. When you start to build something and you're testing it in the real world, whether that's a project or a competition or internship, I think those experiences are incredibly valuable.
Mhm.
Yeah.
And are those the type of things you look for in new hires?
Absolutely. So when we're hiring folks out of college, if they have, solar car team or robotics club, or they did an internship, or they, had a lab class where they built something and they can show me pictures of it or show me a movie of the robot that they built. This is like absolutely kind of top of the list of what we try and recruit for. If they have a 4.0 GPA, but all they've ever done is the homework that was assigned to them, like okay, clearly they're smart, but do they have any of that practical experience?
And in your college experience, did you do any of those clubs?
Yeah, so the my sophomore year there was this robotics competition, and that was, as I said earlier, the thing that got me hooked on robotics. I also did an internship, and it matters a little less what your research was. Like the thing I did, let's see if I can remember. We were studying the ability of alpha muscle cells. I might get this wrong. Basically, when you injure your nerve, the nerve cells don't reconnect. Sometimes you will lose that nerve like for the rest of your life. Yeah. So we were trying to build like a scaffolding structure that would prevent the scar tissue from forming and allow those nerve cells to like reconnect. And so there was these alpha smooth muscle cell something or other, and we had a test bed, and I was testing kind of like some of the material properties of those cells on a substrate. Like this is 25 years ago, but the experience of doing research and working with grad students and being in the lab and actually measuring it, one thing I learned, I spent 2 weeks and I had this weird signal that I kept seeing in my data, and it was 60 hertz. I'm like, what the heck is that? And you realize like, oh, that's like the physical plug, like the current coming out of the wall is at 60 hertz. And I hadn't grounded my, my circuit board appropriately. And so I was getting this noise that was coming in, and like, it's not necessarily about that like nerve tissue regeneration, but you learn those kinds of things and you have those experiences and figure out how to debug something. I never went anywhere beyond that summer doing that, but it's super valuable still.
Yeah, and is there anything in college you wish you'd done differently, or any advice or something you think was really helpful?
Yeah, I mean, I was one of those people who could have majored in like 10 different subjects and been happy doing it. So, I wish I had gotten to do more computer science classes, and I wish I had sort of stayed in applied physics a little longer. And I wish I had, like, there was a bunch of like classes I wish I took, but no regrets. Like doing mechanical engineering was great for me. Mechanical engineering is really broad, and so it leaves the door open for a lot of different careers. And it was hands-on, so that was good. I only did that one internship as an undergrad. Like maybe I would have liked to have done another one, but neither of my parents are engineers. I have like a high school English teacher for a mother and a law professor for a dad. They were teachers. They really emphasized the education part, but I kind of didn't recognize the importance of the industry experience when I was in college. So luckily I had grad school. I kind of didn't get into the workforce for another, 5.5 years after I finished undergrad. But
And then for your current job, like what does a typical day for you look like?
Yeah. Both a good thing and a bad thing. There's not a typical day so much. Once you get a large team, something is always on fire. And so sometimes it's, literally like an electrical cabinet, like you have a fire safety hazard and you got to go fix it. Or sometimes it's, the one person who knows how to fix the bug is on vacation for 2 weeks. And one thing I love about robotics, I will say, that kind of gets at this is it takes everybody. It's very interdisciplinary. So you need hardware, you need software, you need computer vision, you need motion planning. You need systems engineers, people who can think broadly across the whole thing. And so one thing I like about my day-to-day job is I get to dip into all of those different areas and have conversations with really talented people in all of those different fields. At Amazon, we do a lot of doc writing, so usually I'm reading or writing every day. And as a manager, I have a lot of meetings as well. But I enjoy that, right? I like talking to people and mentorship, and so that's a good part of the job for me.
Yeah. And like getting into Amazon, did you always have this position or did you kind of climb into it? How did that work for you?
Yeah. No, so I had been a manager of a small team, 8 or 10 people when I was at NASA. When I joined Amazon, I went back to being an individual contributor. So I didn't have any direct reports, but I was working in the lab doing research on different kinds of grippers for packages, actually, for cardboard boxes, but also like flexible envelopes and the other things that we ship items in. I did that for about a year and a half before I came back into management. And then I got promoted. So I've had, good kind of career progression here at Amazon. Yeah.
And what would you say is your favorite part about your job?
I mean, I love coming down to the lab. So if I ever get sort of exhausted or I have a bad meeting or something, you can come walk around the lab. And the fact that we are building, the robots are here, just seeing them do things that they couldn't do before, gives me that's a sense of accomplishment. And now as a manager, when I see them do things that my team has enabled them to do, I get a similar kind of like high off of that. In some ways it's even better because you get so much more done, right? Yeah. I have a team of this large team that's all super smart and working and delivering. And I feel like, I was a part of this and I was a part of that, even though I'm really kind of a cheerleader for them a lot of the times. But yeah, seeing that robot do things, this is a big draw.
Yeah. And if you had to say what would be your like least favorite or something not as exciting part about your
job? Bureaucracy, administrative paperwork, it is required, but you want to minimize, you want it to meet the requirement and not go any further, right? We definitely need structure. You need to have some of these processes in place, but they can get out of control, and then you end up spending a long time, looking through receipts or doing other kinds of bureaucratic work.
Okay. Yeah. And for your job, even though you're already at such a high level, are you still growing and still gaining skills? And
let me go back. I will tell you the other thing I really hate, and this is why I couldn't have ever been a software engineer. If I'm trying to debug something, I'll hit a limit. I'll get to a point of frustration where I'm I tried to make it do this, and I get a little stuck. So I don't think I could have been a coder. I can write some code, and after about 100 lines, it's better if someone else is writing it. I think part of what turned me away from it is that frustration sometimes I would perk up in me, where I didn't seem to get that with hardware. When something would break, I would be able to sort of figure out how to fix it in a mechanical sense. You asked me the question if I still feel like I'm learning, and absolutely, at a really incredible rate. I think robotics is growing, and there's kind of new breakthroughs every month. And so those offer opportunities, whether that's in AI or in hardware or in new cameras or sensors. I think also now that I'm in this position where I have a big team and lots of different people, I get to learn from them all the time. And so there's opportunities everywhere. And as long as I'm sort of asking questions and engaging, and you have to try and be humble. You don't need to be the smartest person in the room as the boss. That's actually a bad kind of way to manage if you have to be the one that has all the answers. And so, there's a ton of opportunity to learn for me pretty much every day here.
Okay. Yeah. And do you have any parting advice or tips for someone pursuing a career in STEM?
Yeah, I would say one thing, you have to get comfortable with failure. One of my favorite things that I will kind of teach as a philosophy is iterative design. And by that, I mean version 7 is always going to be better than version 1. And so getting quick at building version 1 and knowing it's going to suck and it's going to be broken and it's not going to do everything you want. like that's okay. Like getting through version 1, so you have all these lessons, you can make version 2, and again, like looking for those failures as learning opportunities. You really want to embrace that part of design and that part of robotics and STEM in general. It's like failure is how the field progresses. And there's a lot of kind of cliches you can write about that. Embrace failure, fail fast, right?
Mm-hmm.
Thomas Edison tried, however many thousands of things before he found the light bulb. And so some of them are a little kind of, I don't know, cliche, but I really do think iterative design and like being okay with building something that's not going to work because it's going to teach you about the problem, so that when you get to version 7, it's incredible. Yeah, that would be the thing I would say has been most important to me. Yeah.
Well, thank you very much for your time.
Yeah, it's my pleasure.